Welcome to this CXO science discussion on a topic that's of great relevance today, which is semiconductors, right? My name is Nishant Udupa. I'm a practice director with a firm called Everest Group, and I'm going to be your moderator today. A quick 30 seconds on Everest Group for those who are not familiar. We are essentially a research and advisory firm, and we essentially track the global sourcing markets. So anything to do with outsourcing, offshoring, across verticals, right? And of course, semiconductors is one of them. Now, I said that this is a topic and a market of great relevance today, and semiconductors are essentially ubiquitous today, right? They power all of our everyday devices, whether it's the phones that I see on a lot of your hands, or the tablets, laptops, microphones, everything, right? But think beyond that and think about any emerging or next-gen technology theme, right? Whether it's IoT or connected products, whether it's digital healthcare, smart factory, connected mobility, or even generative AI. Each of these technologies at its core has a chip or semiconductor, right? And this is essentially powering a lot of R&D, engineering, and innovation into this market, right? In fact, I'm going to share some data from Everest Group here, which estimates that the total R&D spending in this market has surpassed $100 billion. In fact, as of 2023, this number stands at close to 110 billion. And it's been growing at close to 18-20% over the past few years, right? And these are staggering numbers, right? And two reasons. Essentially, one, it's a huge market. But secondly, if you look at the growth rates, it hasn't really been impacted by all the headwinds we've seen over the past few years. And we've had plenty of headwinds, whether it's COVID, whether it's the geopolitical situation. And of course, this industry is one that's impacted by geopolitics more than some of the others. More recently, we've had the whole macro slowdown and the economic situation, but none of that has really impacted R&D or innovation to a great extent, right? In fact, what's also happening is it's not just the semiconductor firms that are investing in design and innovation. A lot of OEMs and enterprises are also now getting into it, right? So, for instance, we've got the big tech firms, the Apples, Googles, Microsofts, doing a lot of work on chip design. In automotive, we've got a Tesla and then a few other auto OEMs trying to follow suit. And then in the telecom world, we've got a Nokia or Ericsson trying to do what Huawei has been doing for a while now. And there are similar examples from other industries as well. So all in all, this makes this industry a very exciting one to talk about. And I'm very excited to be having this conversation with 4 panelists today. And let me invite them, one by one on stage. I know all of them have a packed agenda today, so let me not take up any more time today. First up, we'll have Nicholas on stage. Nicholas, if I could please invite you on stage, the first chair here. Nicholas is a vice president at NXP Semiconductors, and he brings over 25 years of experience in semiconductors and power systems business, and he's essentially responsible for leading the company's power systems for automotive and crafting and implementing a lot of their business and product strategies. Nicholas, welcome to the discussion, and I know you must have heard this, but welcome to India as well.
Thank you.
Okay. Next up, Karthik, if we could have you on stage. Executive Director and CEO of Cyient. At least in this forum, I know he needs no further introduction, so let me keep it short. Professor Kiran, I'd like to invite you next up. Unlike our other guest, Nicholas, Professor Kiran has had a much shorter commute today. He joins us from IIT Hyderabad, where he is a professor in the area of wireless communication. Right? He's also the CEO of VISIG Networks, which is leading India's efforts in creating IP in the area of 5G mobile communication, including broadband and IoT. And finally, we'll have Satish. Satish is Vice President and Global Delivery Head of Semiconductors at Cyient. Okay, so let's get things started finally. Karthik, let me maybe kick things off with you, right? So I spoke about R&D and engineering spending being at an all-time high, but this has been happening for a while now, right? The semiconductor industry has always been one which has been R&D intensive. So what is it about this market today that really excites you?
No, first of all, thank you so much for being here today, Nishant, and thanks, Nicholas, Professor Kiran, and Satish. I'm probably the odd man out in this panel, and let me just start by saying, see, semiconductor has been the mother of all innovations, right? It's like I always felt that the root of innovation goes back to semiconductor, and any product gets built, and once it gets sold, you start mastering them, you start miniaturizing them, and start getting into a semiconductor. So it goes through a cycle, and last 5 or 6 decades, if at all products got miniaturized, a cell phone can be carried in your hand. You don't need 3 people to lift it. I think thanks to semiconductors. So it's as simple as that and as powerful as that. Look at the number of devices it has compressed. If you really talk about the software-defined vehicle or software-defined future, everything you can really relate back to your smartphones. And look at the number of hardware devices it has replaced, be it as a clock or a calculator or a video camera or a regular camera or audio recorders, and it replaced all of them. So all this thanks to the kind of semiconductor innovation that was seen. I still hope the Moore's law continues for a while. And it is also about, look at it is one of the richest ecosystem in the world today. And if you look at the technology companies, which is worth about $15-20 trillion in terms of market cap, the second largest ecosystem today is around the semiconductor side. The semiconductors are worth about $8-9 trillion. And thanks to NVIDIA, which has really inspired everyone. And there is a huge gold rush today in terms of moving from CPU to a GPU. And one of the analysts was saying that $1 trillion worth of data centers, which are run with CPU today, need to be replaced in the next 5 years with $3 trillion worth of GPUs just to run the AI workloads. Otherwise, the data centers are not equipped to run the AI workloads today unless they expand by 100x in terms of space and 30x in terms of power. So which essentially means this world is going to be reset. We are moving towards an AI-enabled, software-defined, and how do you think it's going to be hyper-connected, and that is going to be enabled through the semiconductor ecosystem. And which also means when you're talking about artificial intelligence, it is going to start from every walk of life, whether it is how the data will get generated, how it will be stored, memory, how it will get transmitted, how will it be retrieved. So everything has to be faster. So when you talk about AI GPU, it's just not about for storage, but it is going to really have an impact across the value chain. And the kind of money that is being spent in terms of R&D with 15-20% that you are talking about, before end of this decade, I do believe that it will be more than $1 trillion just from semiconductor device companies alone. I'm not even counting on the equipment companies or the ones which are really like ASML or Applied Materials or TSMCs. And if you really put the whole ecosystem together, it's more than 1.5 trillion today. And in terms of market cap is 8+ trillion. So this is one of the most richest ecosystem, and this is really ripe for disruption. And this is probably one of the strongest growth area for us in the next 5-7 years. And that's the reason why we believe this will act as an horizontal across many of our verticals that we operate in. And it fits in the right area in terms of focusing on growth for us in the future.
Wonderful. And Karthik touched upon a lot of themes there, from miniaturization to software-defined vehicles to AI, generative AI, and so on. And I'm sure, we'll dive deeper into some of these themes over the course of this discussion. But what was interesting was Karthik always brings a, business mind to this. He was talking about market cap and $1 trillion and $1.5 trillion. Let me also get an academic perspective now, right? Professor Kiran, if I pass this on to you, what's the role of academia in fostering innovation in this market and driving this market forward? Karthik spoke about a lot of research and AI, Gen AI coming up. I'm sure academia has a role to play there.
Thank you. First of all, I'm very happy to see all the Cyient employees and the management and special guests here. Academia always works with the government and the students and also the industry. So we have many connections. We closely work with all these our partners. If I'm a graduate student or undergraduate student, I would be very excited about getting into this new world where there is so much rapid innovation takes place. Every other morning I open something in the newspaper. I don't read much, but I pick bits and pieces here and there. There is phenomenal action taking place. Especially the processors, they're going to be redefined. Devices like the cell phones that we have today, I think you won't even recognize. This will become like a dinosaur in 10 years. There won't be a cell phone of this kind. The operating systems will change, processors, just the change is rapid. So for students and researchers, this is like the west of the 100 years ago. You just go dig anywhere, you find gold. So very exciting time for those who want to do research. the government is putting a phenomenal amount of research rupees into this space, especially in semiconductors. The premier institutes, they're all given some money to build a chip just about 2 years ago. Okay, and that's just the beginning. Now the government is going to put in a lot more money, but now there is a new effort, which is just don't do research for the sake of doing research. There's got to be an industry and an application. This is the biggest drive taking place across many ministries, both the Ministry of Electronics and other DST and allied ministries, academia, industry, the government. There is a tight partnership expected, and you will see a lot more in this space. I'll stop here. Thank you.
Wonderful. Let me come to you, Satish. So Professor spoke about, a lot of funding being given to places where there are real applications. One of the, applications is in the automotive world, right? And I'll come to you next, Nicholas, but, also taking the perspective of Satish here. The automobile today is fundamentally different to what it was even a decade back, right? We have connected mobility. We are moving towards autonomous vehicles. The software-defined vehicle that Karthik spoke about is, changing the industry. What do you think about, the role of chips and semiconductors in the automotive world today in this intersection?
Yeah. So thanks first of all for having me here. So thank you so much to see all the faces. So I think in the age of the new mobility, I think I would say the vehicles are valued more on electronics than the mechanical specifications anymore, right? Because if you look at, it also puts the companies more and more towards making the electronic parts more optimized and better, which makes this automotive industry move much faster than before. And it has put the companies in such a pressure. We see tech companies like Google and Facebook are into the automotive industry already, right? They are doing autonomous cars already. So before going into the relevance of semiconductor or the software, I want to touch upon briefly on this, the two areas. The one is the factors that drives the mobility, and the second thing is more about the trends that are happening as part of this industry, right? So factors, if you see, there are many factors. I think the important three that I believe are Gen Z and beyond, right? Because the new generation, the way they look or think is more like, they want to experience than own, right? That's the trend is happening slowly, right? And second thing, you talk about societal or regulatory norms. See, for example, 16 to 18% of emission is happening just from automotive industry today in the world. That's huge. So it needs a change and corrections, and it needs to go to EV or hybrids and different ways of driving, right? And third thing is all about increased urbanization. So the moment cities are becoming much congested and more traffic and more, it also contributes back to emission and the time and efficiency everywhere. So these are the things that drives the mobility into a place where it needs innovation, it needs to change, right? So now if you look at the trends that's driving automotive or mobility industry is more like, again, there are many, but I think these are four important things. The first one is electrification that you mentioned in the past. Second thing is autonomous driving. So autonomous driving is all about semiconductor. What drives autonomous is more about the radars, the AI engines running in the system, either to edge or to the cloud, or you talk about the 5G network that connects to the cars. So it's all about, and then sensors finally, right? There are many sensors. You talk about magnetic sensors, LiDARs, radars. It's all ultrasound. They're all sensors that makes this autonomous driving even possible today, right? The third factor I think is more about vehicle to everywhere. We call V2X. It's more like a vehicle to vehicle or vehicle to infrastructure, right? So this is more like making your car to see beyond the line of sight. That's the whole technology, right? It needs, again, semiconductor. How do you see? You connect to the next device or a car in the next 10 blocks, get the data, and find a better way to move forward to your destination. So, and finally, this concept is evolving more and more. It's like mobility as a service, MaaS. So it's more like subscription based. So with this Gen Z concept that I'm talking, it's more like people want to go towards the kind of subscription where pay-per view or pay-per use, right? That's where things are going. So with this logics in place, if you look at now, the two things that's impacting is semiconductor and software. Semiconductor, like I said, it's all about this technological advancements which is driving the mobility. Software is a more important piece. In fact, I was having a chat with Nicholas 2 days back in Bangalore. He gave a very good, interesting analogy, which made me to think better and very deep. He is comparing car to a telephone, right? So I was thinking, why, right? Because if you buy a phone, phone is same when you buy it, but the moment you install your own applications, your apps, your own permits, demands and everything, your phone and my phones are different, even though it's iPhone 15. It's completely different. Cars are usually like, they make a car, you own BMW or he owns BMW, same, there's no difference. Now, because of the software logic coming into play, it's taking the center stage and vehicles are built around the software. So that's how it's evolving and changing. So yeah, to wrap it up short, semiconductor and software is the, I would say, the growth engine that's going to take this industry forward. So,
Wonderful. I think I wish I owned a BMW is all I can say to that. But okay. Nicholas, coming to you now. Anything to add to that? I know you're very familiar with this domain, but he spoke about some of the trends in the automotive industry. But where does the future lie? What can chips really enable? In the future of mobility.
I think the time is very exciting. Very, very exciting. You have a convergence of many technology in one place. So the semiconductor right now is going really into automotive. The automotive is really the new technology coming into place. Along with AI, along with data center, because your car will be a data center. It will be a lot of computing power right there. So the convergence of the silicon, the AI, the power is where everything is converging to one place and where a lot of R&D money is put into place. And so, like you said, your phone, or I would say the car will be a phone on 4 wheels. You're going to be very exciting what's going to happen. You won't have to go to a dealership anymore because they will be able to download the software to fix your car through Wi-Fi. Right, and I don't know you, but I don't want to go to the dealership. It's painful, but now we will be able to download stuff. So this is where the future is going to. Your car is becoming really something that will help you in your day-to-day life to depollute the city, but also to transport you in a faster way, and you'll be able also to continue to read or to watch videos, and that's why, by the way, Google and all those guys wants to play in it because they want to sell commercials to you while you're transporting. They want you to not driving anymore and be able to watch and buy services. So the future is very, 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 very bright, and I'm very excited by this and to be part of it. Second challenge, I would say, the talent, right? And the talent are key, and I'm glad to have the academy here because without university, we will not be able to bring the people that can build all those ICs, and we need talent. So thank you for being here and teaching our people.
Yeah, beyond talent, what are some of the other challenges? Because you spoke about the car becoming almost like a data center. There's the intersection of the automobile and AI.
Yeah.
Talent's just one aspect to that, right? What are some of the other headwinds you foresee in us going towards this vision?
So before a car, it would be 7 years to develop, right? So to be honest, in automotive, we have time compared to consumer on the phone, right? A phone is every year you need to renew your phone, right? So the guy who works for Apple or Samsung, right? They know how time it could be very crunchy in R&D. In automotive, hey, we have 4 years, so it's a different pace, no more. BYD, all those guys now are developing cars within 2 years, and I'm sure it's going to be every year, right? So the pace of R&D is becoming to the consumer way with the quality of automotive, and so that's why I'm very happy also to be here with Cyient because Cyient is helping us to really be able to scale and to go very fast on our execution. The two challenges is pace of execution and talent. That's the two main things that right now I'm focusing on, making partnership with universities to bring the new talents, but also how we can scale, how we can go faster on developing silicon so that it can go into the car every year and not every 4 years.
Yeah. Wonderful. Karthik, coming to you now. Nicholas spoke about the two key challenges. I'm sure, as we go along this journey over the next decade, there'll be plenty of other headwinds that we start facing. Right? In such a situation, what's the role of a service provider in helping OEMs, enterprises, semiconductor firms mitigate some of these challenges?
I think it's a very important element of directionally what is going to happen in semiconductor, and they are the leader of all the root of innovation that I talked about, which essentially brings down to the SWaP-C concept, which is used in defense, which is true for semiconductor and maybe it's originated from semiconductor and taken by defense, which is about size, weight, power, cost, right? So you really want to make sure you want the size of the footprint has to be lesser, and you want the weight to be lower, and you want the power to be, it should consume less power, and it should be less costly. So which essentially means if you look at each of them, it is exponential to add to itself. And now when you're really trying to help them to support on these changes that are happening in semiconductor, it's about how do we build our capabilities and how do we build our framework and processes that drives automation, that drives ability to help the design to be done more virtually simulated instead of doing physical prototypes. And in fact, me and Nicholas were talking about, can we create a digital twin more than a physical twin or physical prototype or sample A, sample B, I think will go away. Everything will be virtually simulated. And if you look at 90% of the physical part of the car is anyway designed virtually. And now when it comes to semiconductor and electronics, you start creating the system models, you really keep transferring the system models, which can be useful for making the testing and validation while you are still working on the physical part of it. So how do you think some of them that service provider like us can help in terms of helping the customers to achieve the time to market advantage through automation, through process frameworks that really start taking lesser and lesser manual efforts that are required to complete the design? And when you also move to a software-defined architecture, even if you take semiconductor side, where one of the semiconductor customer was telling this to us, saying that in 40 years, they've designed the hardware and then they designed the software that will be leveraging the hardware ports. In the last 5 years, they started defining the software architecture so that they know exactly what ports are required from hardware. They said 20 to 30% of the ports were never used in the past, because the hardware got designed first and then the software came in. Now with things reversed the other way, the software will pick what hardware configuration or specification that is required. And this is going to create multiple variants without you needing to have many hardware devices, and you can actually make the configuration happen in the software more than on the hardware side. So how do we help our customers in moving more and more to the virtual, simulated, and be able to really drive through with software-led? I think that's an opportunity we see as a partner working with customers like NXP.
Wonderful. And I think that's true not just in the automotive world, right? The software development life cycle is essentially something that's much faster than the hardware development cycle, right? And that's a transition we are observing across industries, isn't it?
Yeah.
Satish, coming to you now, and let me take a slightly different track, right? If I look at the global semiconductor industry today, the industry is in a state of flux, right? If we look at chip manufacturing, there's a lot of talk of moving manufacturing away from the East, right? So there's talk of diversification and chip manufacturing reshoring and localization, and similar things are happening on the engineering front as well. So in this situation, amidst such an environment, what's the role of a country like India?
Yeah. So before going to the country of what India plays in these ecosystems, I want to touch base a little bit upon this semiconductor ecosystem a bit, because if you look at 40 years back, right, every company that makes a semiconductor chip used to have their own foundry. That's how it started. But guess what? After 30 years, 40 years, it became the fabless concept came into play, where companies wanted to do only chips, and it kind of gave birth to two important ecosystem partners. One we call the third-party foundry players like TSMC, UMC, SMICs of the world, GFs of the world. Second thing is the OSATs, outsourced test and assembly. That's how it all got born into play, right? So what I'm trying to tell is this ecosystem is like constantly evolving, and finally it settled like 20 years back, this model. Now, if I look back, the kind of things that's happening in the last 2 years, looks like this ecosystem is changing a little bit. The way it is changing is, it is all coming from the people are taking or challenging the status quo and trying to go up the value chain. What I mean by that is, if you take a tier 1, like NXP, for example, or any other company, they want to go from a chip provider into a system provider. That's the shift is happening. If you take the another partner in the ecosystem, like IP provider, they are moving from supplying a traditional IPs into a subsystem or a chiplets. A chiplet is more like kind of you make one die which can come in a single package, which serves the same purpose in multiple products. That's the chiplet, right? So they try to do that right now. Take the service provider. We are a classic example. Where people are moving from services into production and manufacturing and software as a complete product development for the customers. Right. So the point is, this ecosystem is constantly changing, and it is and with this Gen AI coming into play, it's even more transitioning much faster. This is like important catalyst. So in this context, how we see India is playing. So I think India has the fundamental strength I see is the talent, which already supplied. For example, 20% of the talent in this entire semiconductor supply chain is from India today, right? Which is a significant size, and 50% is contributed by US, China, and India together right now, which is like 2.3 million engineers across the world. That's a lot, right? So now that I think we need to position and continue growing that part. The second parameter I see is how India can play is the demand. India is contributing 5% demand today in the entire semiconductor ecosystem. But the population growing and then kind of new generation coming in, this kind of concepts of digitalization, everything in play, this demand is going to grow only more and more, right? So these two aspects, I think we have a good chance where India can play a major role both on talent and the supply, the consumer point of view. The challenge is on the IP and the manufacturing, because these two things are much slow. We are late in the game, and thanks to folks like Professor Kiran, who's running this IP initiative in India right now, where they're the leading 5G IP providers right now with the startup mentality, thanks to the government of India schemes like a DLI, Design Linked Incentive, which is encouraging companies like this, and PLI, which is encouraging on the production side. So I think these two are the key for going forward, and for that I think these kind of schemes are going to help a lot. So I think India, in short, will have a bright future. Definitely talent and the supply, definitely consumer point of view. With IP and manufacturing supported by government, there's a huge play. It can contribute. In fact, more than play, I think it can even drive. The risk or challenge is that we should not be complacent, because with the technology keep changing continuously with the Gen AI and everything, the existing 20% workforce needs to be relevant, and that's more important. So we need to be relevant, increase and move forward. So that needs a lot of work with industry and academia together, and the companies to see how we evolve it. But the future is bright. In fact, more than contribution, I would say it can drive the future.
Wonderful, wonderful. And Professor Kiran, coming to you now, I think what Satish touched upon there was the talent supply in India. And India has always had a lot of talent, right? We are blessed with a great population. But even beyond the supply of talent, I think there's also a lot of innovation that's happening in the country. And I'm sure you would have seen firsthand the kind of projects and the kind of stuff that a lot of startups are working on, right? Can you share maybe a few examples from the startup ecosystem in terms of what you've seen and the kind of innovation that's happening in the country?
Thank you. So the design-led incentives, DLI, what they call, has given grants to 11 companies in India. This is by the government. About $2 million reimbursement they gave to 11 companies. Out of these 11 companies, I think 2-3 of them are modem companies, like 5G kind of modems. And the rest of them, most of them are processor-centric companies. There are a couple of them doing very interesting processors. Okay. So what it says is that these 11 companies actually have existed despite not getting venture money or any encouragement whatsoever. These are just keen individuals who did it. We're one of them. Vysig has done. Of course, we came from the university. We did a 5G class of chip called narrowband IoT. It addresses a certain segment of Internet of Things space. We have done quite a bit in the modem space. We're fairly confident if you have to build a chip on the modem side, especially for devices, not for smartphones, but for Internet of Things. We can practically deliver any kind of chip with the kind of groundwork we have done over the last 7 years. That aside, what is really required is that the investment by the government, this 2 million is just a small drop in the ocean in this business. It has to be, an order of magnitude higher. For that, of course, government cannot put all the money in. So venture money is required for these 11 companies to go to the next level, and 11 companies become 110 companies. It has to be, there has to be an order of magnitude increase in the number of companies as well. As far as the government is concerned in India, the appetite is very high. That is to consume domestically created technology for various reasons, supply chains, national security, whatnot, right? The appetite is just enormous. But of course, a lot of groundwork needs to be done. These are early days. But I think there is a reasonable chance that a few companies will come out and start doing fabless chips on a reasonable scale. That's my kind of prediction. We'll see. Time will only tell. Thank you.
Wonderful. Nicholas, just to maybe round this off, and Professor Kiran, myself, a lot of people in the audience as well perhaps are seeing this from the inside. As an outsider, where do you see the role of India? What's the potential? What does India need to do more of?
First, a little bit of some numbers. For NXP, 33% of the engineering workforce come from India. You have a huge power, which is number, right? You have a lot of people, but also a very good university. So the play of India is critical in this efficiency, in automation. People tend to oppose software with hardware. No more. Hardware and software is going to be like that. And India has a unique capability and ability to have both the hardware knowledge and the software knowledge. So I would say use that to your advantage, because you have a huge advantage here. Coming from the software, coming from the hardware, putting that together, right? That's to me a huge value for the country, right? The scale, the number of people, the innovation that you're going to bring, and the knowledge you already bring, because you're not new to the semiconductor. It's been years and years of development with us and all of that, or with even Italy. So I think this is a huge value for India. So that's my view here. Continue to bring the software and the hardware together to bring innovation. That's for sure the next level for India.
Karthik, anything to add?
No, I think if you really look at it in terms of talent pools with aging workforce coming from Western part of the world, and if you look at the STEM graduation and number of people who are crossing 65 plus years from US and Western Europe is about 6.2%. And the graduates coming out of the school with STEM background is about 1.4%. So this 5% differential is going to really be tough to really bridge unless India has a very important role to play. The second biggest thing is the change is happening more favorably so from India because of the software-led growth that is going to be seen. And if you look at last 100 years, maybe 60, 70 years were led by steam engine to IC engine, mostly by mechanical engineers who really led most of the product development. Last 30, 40 years, it was led by electronics, microelectronics, semiconductors have really helped to lead the growth. And if you look at the next 50, 60 years, it is going to be software and AI. So now this is naturally an advantage for India to take advantage in this area, where the biggest challenge that I've seen working with many customers in the last 3 decades is lack of physical labs. We don't have those heavy labs around us. So how do you make sure that we don't have the factories and we don't have the integration facilities that can be seen along with the products? Now, all this may be an advantage because you can create everything in a virtual simulated environment. You can actually make it to count in the physical one is only just a validation, because 98 to 99% can be done in a virtual environment. You can really put to the production without going through a significant test and validation that is required. The third important thing is the number of tools that has been built over the last 20, 30 years. Now I'm sure the silicon design is going to be done out of cloud. So you're not really dependent on certain configuration of hardware and other things, and the restrictions are gone. The kind of tools from Cadence and Synopsys have matured over a period of time, and you can actually be able to take advantage of the development that has happened in the tool, and with digital twin and some of the concepts that can be brought into the VLSI design will also help to shrink the time to market. So I genuinely believe India is at a natural advantage in terms of trying to take a significant step. I keep using the word saying that the center of gravity for semiconductors is in India, with almost close to 20 to 22% of the skills are available within 1,000 square kilometers. Bangalore, Hyderabad, and Chennai, if you really look at, this is where most of the semiconductor skills are available in India. With that, it is almost a single concentrated group of VLSI engineers that you can find anywhere else globally. Now, with that advantage, India should really strengthen with VLSI plus the software and digital skills, should be in a better position to leverage for the future.
Wonderful. I think lots and lots of takeaways for the audience from that discussion. But I think what's been key for me is that there are lots of reasons to be bullish about India. Hardware and software development has to go hand in hand. In fact, hardware, software, digital, it's all changing the world. And I think AI is going to be a true disruptor, right? Not just in automotive, but across industries. With that, I think we have time for a couple of audience questions.
So good afternoon to Karthik, Nicholas, Satish, and Kiran. So my name is Ramulu. I'm a DFT practice head in semiconductor group in Scient. I think a lot of wisdom we got today by all of your discussions. So one of the key buzzword I always hear nowadays AI. I think the Karthik and other panel members also touched about on these things. So I think last month I also see that now Synopsys announced some great thing in their tools with AI. So what will be the vision here? AI coming to the market. I mean, in the implementation side, how do you see the semiconductor future with the AI? Because one side we talk about a lot of creation, innovation with the talent pool in India. The other side, which is enhancing the capability of human creativity by using the AI technologies. So right now already we're touching about 2 nanometers. What is beyond that? So where are we going to launch? Where we are going to land?
I think maybe I'll take a shot at it and request Nicholas and Kiran to add. So if you look at, there are 2 parts to the story, right? One, every semiconductor chip will have to have some AI component in it, whether it is memory, storage, compute, or transmit, or connect. I think all of them need to have some element of AI component in it, right? That's the way in which how the future is evolving. In fact, most of them, I was talking to one of the storage and the memory company. They said they are really seeing that how do they really create a high bandwidth memory is going to be the future, because if you need to flow the AI workload through a pipe, the pipe has to be smart enough to really handle the AI workload. It's just not about your end edge analytics or cloud and how does it get transmitted from edge to the cloud. So that also need to be smart enough. So they were really saying that now what you want to store in the phone versus cloud, and how do you think you can really manage the memory that is going to store here, and that has to be smart. And Nicola was talking about something on energy management within the car. If you're going to have domain controllers covering various different parts of the car, and each of them need to know how much of energy it is consuming from main battery. So you should ensure that it is optimized on a continuous basis. That means each of them need to have some kind of an intelligence. So there is an intelligence that is going to be added to every part of the silicon that is going to roll out in the next decade. Irrespective of you are just on the GPU side, doesn't mean that AI won't be required across all the other silicon companies. The second part is the design part, where we come into picture, which is also very important for us to see how do you think we can reduce the time to market. Can you use the cloud-based design tools? Can you really find automation for test and validation? Can you really use AI-based number of test cases that you are trying to validate? Can that be shrunk, or can that be run automatically without manual intervention? So a lot of things that are being done manually today, how much of it can be virtualized? How much of it can be simulated? How much of it can be digitized? If you really see certain modules, that can you really create a math model that can be tested and validated. So if you're going to use the same math model, it is going to reduce so much of test and validation time for you in the future. So how do you really create the modular components that are pre-tested, validated, like a library that you may have, and you can still use 30, 40, 50% of the components from library that will really help you to reduce essentially the design cycle time. So that's where we have an important role to play in terms of through virtual and simulated environment and automation as a tool to really reduce the time to market effect. I think that's where we have a very, very important role to play. Satish, you want to add anything?
Yeah, so thanks Karthik. I think just to add, I think he covered most of the points. So if you're talking about tools, implementation, redundancy, if that is where it's going, I think the AI in the tools needs to be looked at efficiency improvement primarily. For example, if an engineer is sitting and doing a report, staring at it for 2 days, this AI engine can actually give you the analysis within 5 minutes. But still, the human will end up taking a call whether to go or not to go for tape out. For example, I'm just telling. So EDA companies will invest more and more in AI. That's what is going to happen. That's eventuality, right? The question is, how are we going to use these tools effectively to improve our efficiency, performance, especially what he said on time to market is the key. In fact, Nicholas said, if you recall his point, people are thinking, in fact, he said that either to do a 12 months first time right silicon, or you do with 90% accuracy go for 6 months tape out. The people are thinking that kind of thoughts right now. So it's all about time to market, catching the bus. Otherwise, we're lost. So this is all like going to help us to go there. Is my view on this. EDA companies are getting into AI. That will happen more going forward, I believe.
Okay, yeah, great. I think at least now I can see that, right, by AI coming to the picture, right, we will be leveraging that to improve the time to market and improve the product quality and stuff like, no, other end people see software side, they may lose the jobs, all things. So that's not the case, at least in some.
That's not the
I'm
case,
glad
yeah.
to that. So like, no, coming to Kiran, right, I think I know Kiran, we closely worked on Rising project. I'm fortunate to be part of his in that collaborative work. So Kiran, nowadays, right, like what I see, at least my personal opinion, right, what I see is as industry wise, we need a lot of talent. We have a lot of requirements. Even if you see, like Satish can say, we need 100-member team. That is true. But now what I see the gap is right now, there is a clear gap between, it's my personal opinion again, I see a clear gap between the academics and the industry requirements. So today when I go for a campus interview or any recruitment, right, I can easily find the gap. Even though, academics, say they are good at academics, but what industry looks, that we are not able to find in the right now currently where we are going and getting the people. So how do you see to bridge this gap?
Yeah. So first, before I answer that question, people in this room should not be worried that you are not going to lose your job. The AI has other problems to solve, not replace your jobs. I can be sure of that.
Yeah.
It's not going to do RTL coding. It's not going to do verification. It's not going to do physical. They're all anyway heavily automated already. So don't worry about that. But of course, the sad part is AI is going to eliminate a lot of jobs. This is the truth. And this is going to be reality. We have to be prepared for that. Some fields, it's just coming very fast. Answer your question. So fundamentally, the role of universities is to teach the science and engineering. Okay. So what we focus on is mostly on first principles, right? We want to give a very good grounding on first principles, and so that the engineer can live and learn rest of the things, on their own. But I see that, industry has this immense need for the real world skills, right? Which are engineering skills plus there is something specific to designing products. We don't teach that. So what the possibility here is that in addition to the regular curriculum, which has been there for last 50 years, right? Same courses, maybe they have evolved a bit, maybe in VLSI. There needs to be a different kind of a teaching, which we do, by the way, for communications. We do that kind of teaching. We have a program that takes that graduates about 100 people a year, and we impart basic skills, electrical engineering, embedded software, communication, basic skills. And these could be anybody, a student in the final year or anybody looking for a job, a person with a polytechnic degree. We don't discriminate them. We have a program running, it's called Future Wireless Communications. But we could possibly think of a program on the VLSI part. Okay, we haven't done that. That will potentially address your needs from basic sciences, fundamentals to day-to-day engineering. We can do something like that.
Yeah, exactly. Thank you.
Just to add, right, I'm seeing a trend where there are a lot of training institutes in India right now evolving very heavily with the given situation. And I'm also hearing that they're actually partnering with the colleges, especially. And on the third semester, fourth semester, they start partnering. And they're trying to take some of these requirements that you said on the industry, they're trying to get into it. And it's not like coming into the regular stream of courses, but it's like an optional stream. They're building it right now. I think it will take some time, but good part is it's happening already. So it will take its own runway. Maybe another 2-3 years, you will see that the difference will keep lowering. But yeah, maybe today it is there.
Okay.
If I may, to me, I'm a true believer of partnership. The same thing, we have a very good partnership here. Partnership with university is key. Every single R&D manager within my team have a strong tie with the local university. So last week I was with ASU in Phoenix. We talked about that because you can influence the curriculum. You can even go teach. They would be happy to have you teach DFT in university, right? We have the power to influence the university. Universities are there to bring people for us industry, right? So it's our duty to go and tell them, this is what is coming, please teach them. And they're gonna say, yes, we can, also you can help us. So go create a strong relationship with university. Tell them what is your need in 5-10 years. Go and help them go do some, how do you call that, lectures, create classes, go teach your people. That will be very important as well.
Yeah, just to add on that, we have
Yeah,
something
that's-
called a professor of practice. So, of course, it has its own criteria, but the idea is that you are not a PhD who is not practicing like an academic professor, but we're actually practicing the art, that is your engineering. So you are allowed to come and teach the students, and you are called a professor of practice. So the companies have to invest, right? You have to relieve your best chief scientist 20% of the time to go there, teach, and the fruits start flowing back. So it cuts both ways.
Yeah, you remember in 2022, we have this war of talent. Everybody was looking for experienced people, but the number of experienced people are same. So if you want to grow, there is no other solution that go with university, bring more talent. And actually the younger generation, right, they will bring new views, new way. They're going to be agile with the AI, like you mentioned, right? By the way, we should not be afraid of AI. New technology is freedom for humanity. That's my view. Look at the boom of technology we had the last 20 years. So yes, as you mentioned, it's going to destroy jobs, but it's going to create much more jobs as well. So these young talents from the university will actually help us transition to this technology. So we need to have this talent pool. We need to have a partnership with the university to increase this talent pool, to avoid the talent war we have 2 years ago.
Okay, yeah, great. Yeah, thank you. I think so at least my takeaway is like, no, industry and academics should work collaboratively, very closely, so that no, we can solve together our own problem. No one can come and solve our problems.
Thank you.
Then us.
I think we have time for maybe one last question, if anyone wants to go.
Yeah, my name is Madhav Reddy. I'm taking care of DV manager here. So my question is, right now in these past years, Indian government is supporting Make in India many other ways, many other products. So they achieved also in many other products wise. So in semiconductor area also they are planning supporting their policy, changing the policies accordingly. I think they are planning for building a fab also in the near future. I think I heard some near Mysore or somewhere. So how these policies will help Cyient to grow semiconductor business?
I think I would just say that India is still far down the lane for us to get self-reliant on the semiconductor side, right? I think every country, like what Nishant said in the initial discussions, this has become a geopolitical tool, geopolitical war, geopolitical challenge. And I think Europe has created CHIPS Act, US created a CHIPS Act, and China is getting alienated, and they may not get all the technologies, especially on the lower nanometers. They will not get the technology. So this is going to be something that we are going to live in a world where the same design need to be replicated for different nanometer of nodes on which you have to manufacture. But if you look at India has an advantage when India is trying to look at something about creating a semiconductor ecosystem. I think it should start from design. It should start into analog. It should get into some of the mixed signal. And before start getting into the low nanometer digital silicon. I think that's how we should really focus on. And in fact, me and Nicola were talking about it, saying that you don't need to have everything has to be in 2 nanometer or 3 nanometer. The question would be, yes, I think some of the high performance compute and artificial intelligence would need the low node manufacturing capabilities. But India should work on, even if it is 130 or 28 nanometers, which is good enough. And can we really start getting the design that can be done within India for telecom, defense, something of national security? And how do you think they can really start promoting it for some of the consumer appliances and maybe some part of smartphones that are sold in India? So that's how they're trying to really come about. It is still about, I would say, about 5 to 7 years away before India can say that we can really be able to get everything done locally. And I still believe a lot more can be done on the fabulous design part. Can we really start getting more on the value chain? If you really think about it, still going to be on the design part. How do you think we really master the design part? We hold the design and probably be able to get it manufactured wherever it makes sense. Even some of the fabs, maybe Nicola can count on it, whatever is coming in US and Europe, how far are they efficient compared to global standards are? Because I believe if you are not making 95% yield, you won't make money in the fabs. So it is very, very cutthroat business. It takes long time to master the manufacturing out of it. While you're talking about design and engineering part, manufacturing is equally tough as well. So it's not going to be easy for anyone other than, I think Taiwan has specialized it over the last 20, 30 years. Difficult for many countries to replicate that in a short span of time. It will take many decades before which they can really start making money on it. Any view that you have?
True. To build, I mean, NXP is going fabless, right? Even though we have analog, technology embedded to NXP, we want to be fabless. Because you have to understand that to build a fab, right? We just heard yesterday that TSMC is going to build a $6.6 billion fab additional you have to have 6.6 billion available. Of course, government is helping you, but you need that money to go and build your fab. And this is constant, because well after 2 nanometers, 1 nanometers, even below, right? It's a huge amount of money to go there. It is not a play that where the semiconductor companies, most of them want to play. It's too much capex, it's too much investment. There is people who do it very well. TSMC, GlobalFoundries, they have years of experience on building this technology, investment, and cash flow. This is their job. And the same thing, like we talk a little bit, right? Everybody needs to focus on what they're good at. TSMC and GlobalFoundries are extremely good at building fabs and building technology. Our job is to really leverage that. By the way, right, I think there is this struggle play between China, US, Europe, but the business, they want to make money with everybody. Right? So, yeah, we will build locally, we will design locally, we will manufacture locally, right? Because even though TSMC right now they are building in US, they might build in India, because if India become a big market, they will come to you guys because you want the supply chain to be sustainable. So everybody is going to be a winner on this one. There is a lot of things going on. The market is growing, booming. The demand for semiconductor is booming. Everybody will have a piece of the cake. I'm not too worried about that, to be honest. But focus on design, because I think that's really where the innovation is going to be.
Thank you.
Thank you. Wonderful. I think that's all the time we had for today. Thank you to all the panelists for the ideas you shared, for the insights, for the discussion. Thank you very much for your time. I really appreciate it, and I'm sure the audience also really values the insights. Thank you so much.